Hello, continuing with variables. In the last couple videos we learned that we use a variable whenever we want to remember something, that a variable is a name for a place in memory where we could store a value. We store a value by using one of these assignment statements, such as dark gets the value of the robot on dark expression. We learned that meant that Java will evaluate the expression on the right-hand side first, and then assign that value to the name on the left-hand side. And if we simply remember the phrase gets the value of, it will avoid a whole bunch of confusion with this otherwise terribly chosen equal sign, right? The equal sign, I think, is confusing. It triggers thoughts of how equals works in mathematics class, but in Java and in many programming languages, it simply means gets the value of. Alright, and we also learned that in order to use a variable, we have to assign a value to that variable. Don't just ignore what I just said. In order to we learned how to assign a value to a variable, but we learned before we do that, we have to declare to Java that we intend to use that variable name to store a value of that type, and we do that with a declaration statement. And you saw that here when I declared that dark was going to store a Boolean value, and from that point on I am allowed to start storing Boolean values in it, and then use that variable name to retrieve whatever Boolean value I store in it. Alright, I want to take a look now at the life cycle of a variable, so I think that will help us. So, life cycle of a variable. When is a variable born? When does a variable die? Yes, it's going to be a sad story. Here we go. Variable is born. Then we start using that variable. Maybe we assign to it. Maybe we reassign to it. This is not going to be actually a useful program. Don't worry about that. Maybe we reassign to it. And then at some point we end whatever block we were in. And that's when the variable is going to die. So to help us appreciate this, we're going to call upon our good friend Java. So here is, Java looks better like this. Here's Java, and as usual, Java is a little blob. I don't know if I've drawn this picture in this sequence of videos yet, but I love drawing Java like this, where it's a blob with two little feet, and of course Java needs feet if it's going to be able to jump up and down and get from place to place. And Java, and I should point out something actually. In all the examples we've looked at so far, the computer has had to remember something, and whatever the computer has had to remember is reflected in, here it is, in the state of where the robot is, which way it's facing, what squares are dark or light, and so on. That's not true with variables, right? You can't tell from this picture at any given point whether the variable dark contains the value true or false, although you can reason about what it should contain if the program works correctly. So variables not only remember values, but they remember them in a way that we can't visually see as we run the program. So we're going to draw that Java is remembering a value. So that's why you see Java here with this thought bubble. And the first thing that happens when I look at this program is Java realizes, you're going to use a variable called x, and it's going to store a Boolean. So Java makes a place in memory for it, calls it x, and it will one day store a Boolean. But it doesn't actually have a value yet, so I'm going to write it as uninitialized, like this. It doesn't have a value. Alright, so if we're stepping through our program, when we get to this line that says x gets the value of true, at that point, x no longer stores this, right? No longer stores this uninitialized value. It stores true. Okay, so at this point, x is storing true. Once we've, in fact, let's start writing down some of the key ideas here. So this means we are declaring that we intend to use this variable. Here we're assigning to it, and the very first time we assign to a variable, we call it initializing. And the reason we call it initializing is because we're giving x its initial value, its first value. It's almost like we're firstizing, right? We're giving x its first value, and x's first value is going to be true. Because it's a variable, we can vary what value is stored in that variable. We can change our mind like we do on the next line of code. But the very first thing we do after declaring a variable must be that we give it a value. we can't, if we were to get rid of this line here that initializes x to be a value, and we start using x like we do down here as if it already has a value, and it doesn't, then our program won't even compile. So we do need to give it a value before we start retrieving its value. That should make sense. You need to store a value in memory before you can retrieve it. So here's us storing the value in memory, storing true in x, and here's us retrieving it and then doing something with it. So what we're doing with it is we're negating it, and the opposite of true being false, and then it says x gets the value of not x, so x is going to get the value false, right? Not true is false. And when x gets that value, that means it's no longer true, it's now storing false, so Java's remembering false. And then at some point later, we encounter this closing brace here, and the closing brace is where the variable dies. Variable dies. Java forgets x. So here's x being forgotten. At this point, Java does not remember x. If you ask Java about x at some point later, if we were to write, I don't know, return x or something down here, Java would get upset and say, whoa, I've never heard of x. And so our program wouldn't even compile. The moment we hit that closing brace, the variable is forgotten. And as far as which closing brace, it's the brace that corresponds to the block of code where the variable was declared. And we're going to go through some subtle examples about how that works in just a second. I want to point out one more thing about variables before we get into that, and that's if we were to say x equals true, and let's assume x and y are already declared to be of type Boolean. Alright, fine, we won't assume that. We'll do this right. If we say x gets the value true, y gets the value of x, x changes to false, what's the value of y at the end of this code? Right? Is y true or false? Now let's follow through what Java would think about these. So we've got x, we've got y, and they're initially, they don't have any value, but then we initialize x to be true. So x will store the value true. And then we say y gets the value of x. What does that do? It means look up the value of x, retrieve that value, which is true, and store it in y. So y gets this value true. Notice y does not get x. X isn't what's stored. True is what's stored. Only values, and the only two values we know so far are true and false. Only values can get stored inside of variables. So y gets the value of x, y has now gotten the value of x. And then when x gets false, that means this x up here is now storing false, and y does not change. So I want to note that y equals x does not in any way link y and x permanently. It just says, look up what the value of x is right at this second, and store that value in y. And then forget that y ever had anything to do with x. Y and x are not linked in any way. Okay, some more lovely ugliness with Java variables. Oh, by the way, notice when I make these little goofy diagrams with Java and the feet and so on to keep track of the values of x and y, you're going to find that you do this too. You may not draw Java with the feet, although it's so much more fun if you do. But you better keep track of what are the values of your variables, because you won't be able to see it in your robot world anymore. And if you want to figure out what exactly your robot or your program is doing, and you want to trace it on paper, you're going to find yourself often writing the values of the variables on paper and then following what happens to them. Okay, suppose that, I think I'm going to start this in the next video. So in this video we took a look at the life cycle of a variable, but we didn't explore some of the weirdness that can happen if we're not careful and we don't pay attention to the life cycle of variables. So we'll continue this thought in the next video, and I'll see you then.